Today's lesson is parallelograms in the coordinate plane. Okay, so we are going to use slope, the distance formula, and the Pythagorean theorem. All right, for example number 1, we are going to talk about the property of parallelograms that the diagonals bisect each other. Find the coordinates of the intersection of the diagonals of parallelogram L, M, and O with vertices at L, M, N, and O, and the distance of each diagonal. Okay, so just to review the midpoint formula, I add my two x coordinates and divide by 2, and I add my two y coordinates and divide by 2. The distance formula is the square root of the difference of the x coordinate squared plus the difference of the y coordinate squared. And the Pythagorean theorem is the hypotenuse is the leg squared plus the leg squared, and then I'm taking the square root of that. All right, so let's start out by, let's plot the points. So L is at 1, 4. So I am going 1 to the right and 4 up. I always start at the origin. So 1, 1, 2, 3, 4. This is L. M is at 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. This is M. N is at 6, 0. And O is at the origin. Okay, so here is my parallelogram. Okay, so it's first asking me to find the distance of each diagonal. So the diagonal is from one non-consecutive vertex to another. So it's asking me to find the distance of each diagonal. So to start out with, I'm going to find the distance of diagonal LN. So L is at the coordinates 1, 4, and N is at the coordinates 6, 0. Okay, so I'm going to call this x1, y1, x2, y2. So I'm going to substitute into the formula, or to find, first I'm going to find the intersection of the midpoint. So I'm looking for this point here. And I could do either diagonal to find the midpoint. So I'm going to just use L and N. So substituting into the midpoint formula, I'm going to just call this midpoint 2, just so we have a name for it. So x1 is 1, x2 is 6, divided by 2. y1 is 4, y2 is 0, divided by 2. So 1 plus 6 is 7, divided by 2. So that's 7 halves. And 4 plus 0 is 4, divided by 2 is 2. And usually when we're talking about the coordinate planes, we'll write those in decimals. So this is going to be 3.5, 2. And if I look, my point 1, 2, 3.5 and 1, 2 is really basically where I drew it. So here's the midpoint of the diagonals. Next I'm being asked to find the length of each diagonal. So I'm going to use the distance formula on 1, and I'm going to use the Pythagorean theorem for the other diagonal. Okay, so first let's use the distance formula. So I already have my points labeled as x1, y1 and x2, y2. So substituting in, x2 is 6 minus x1 is 1, quantity squared. Y2 is 0, minus y1 is 4, quantity squared, and I'm taking the square root. When I put it in my calculator exactly like this, I get the distance from L to N is approximately 6.4. Okay. Next, let's find the distance from M to O. So I want to make a right triangle. So from M to O, I'm going to make a right triangle. So I'm going to break down this to the horizontal and the vertical components. This is 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4. So I'm going to break down the hypotenuse into horizontal and vertical. So I'm going to substitute in the horizontal for A, the leg for A, and 4 for the leg for B. So I'm going to get the distance from M to 0 is going to be the square root of 7 squared plus 4 squared. So I get the distance from M to 0 is approximately 8.1. Okay, let's find, it's your turn. I'm going to have you turn off the video and tell me what you get for finding the midpoint and the distance of each diagonal. Okay, so let's see, how did you do? So let's plot our points first. The coordinates are S is at -2, 3, -2, 3. T is at 1, 5. U is at 6, 3. And V is at 3, 1. Okay, so here is my parallelogram. So I want to find the intersection of the diagonals. So the intersection of the diagonals is going to be the midpoint. So I notice I have a horizontal line here. So I'm going to call this the midpoint. So I can just count halfway, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. So if I count 1, 2, 3, 4, I'm here. So the coordinates for M are at 2, 3, and I came to this conclusion just counting. Okay, because I have a horizontal line. Okay, let's find the distance of each diagonal. So diagonal S to U. Again, this is a horizontal, so I'm going to just count. So I know this is 1, 2, 3, 4, 5, 6, 7, 8. So it's horizontal, so I just got this from counting. And let's find the diagonal T to V. So I'm going to use the Pythagorean Theorem. So I'm going to break down T to V into a right triangle. So horizontally I have 2, and vertically I have 1, 2, 3, 4. So substituting in the square root of a squared plus b squared. So I'm going to say a is 2 and b is 4. So 2 squared plus 4 squared, and I'm going to take the square root. And rounding, I get The distance from T to V is approximately 4.5. All right. Okay, this time I'm going to talk about opposite sides are parallel. So 3 vertices of parallelogram, W, X, Y, Z, with vertices W, X, and Z. Find the coordinates of the vertex Y and verify. Show proof that the opposite slopes are equal. Okay, so this is going to be about slope. And I know that slope on a graph is rise divided by run. All right, so let's plot our points first. So W is at -1, -3. X is at -3, -2, -3, -2, -3, +2. And Z is at 4, -4. Okay, so when we are naming our polygons, we name them consecutively. So it's going to be WX. So I know Y is over here on the top right somewhere, Z. Okay, so I know so I want to find the coordinates of Y. Okay, so I know I'm going to have the same slope. So the slope to go from W to X, the rise is going to be 1, 2, 3, 4, 5. And the run is going to be left 2. So I'm going to do the same thing from Z. 1, 2, 3, 4, 5, and left 1, 2. So when I put this in, the coordinates for Y are 2, 1. Okay, so and the proof has to do with the slope. So I want to compare the slope from W to X. So from W to X, we said the slope is rise over run. So slope rise is going to be 5. And I went left, so that's -2. And this slope is supposed to be congruent with this slope. And this is from Y to Z, which is going to be 5 and -2. And these two slopes are equal. Slope for X and Y. So from X to Y, rise is going to be -1 and run is 1, 2, 3, 4, 5. So down 1 and to the right 5. So down 1 and to the right 5. And W to Z. So down 1 and to the right 1, 2, 3, 4, 5. So down 1 and to the right 5. So these two are equal. So that's my proof. So by definition, a parallelogram is a quadrilateral with opposite sides that are parallel. All right, I'll let you try the next one. Can you pause the video, answer the questions, and then check and see how you did? Okay, there's 3 vertices for quadrilateral or polygon parallelogram A, B, C, D with vertices at A, B, and C. Find the coordinates of D. So I'm trying to find the coordinates of D. And then verify their slopes. Okay, so let's plot. A is at 2, 4, 2, 4. B is at 5, 2. C is at 3, -1. Okay, so we got ABC. So I know the slopes for here and the slopes over here are going to be the same. So if I'm going to go from here, rise over run, so rise is going to be down 1, 2, 3, and left 1, 2. So down 1, 2, 3, and left 1, 2. Okay. So here is D, and D is at the coordinates 0, 1. Okay, so we said the slope was down 1, 2, 3, and to the left 2. So that is slope BC. So that was down 3 and left 2. So -3 divided by -2 is 3/2. And we did from A to D, down 1, 2, 3, left 2. So -3 divided by -2, which is positive 3/2. So these slopes are equal, so these are the opposite sides. And slope A to B, down is going to be 1, 2, and run 1, 2, 3. So down 2, to the right 3. So this is the slope, so down 1, 2, to the right 1, 2, 3. So down 2, to the right 3, and these two slopes are equal. Okay, that's it. We are all done.